Welcome, dear listener, to the Sleepy Science Facts, where we drift into the depths of the universe to explore cosmic wonders and let our minds wander freely into the mysteries of the cosmos. If you're here, it's likely that your day has been long, or perhaps you've always preferred the serenity of falling asleep while pondering the vastness of space. Whatever brought you here, I'm glad you found your way to this tranquil journey. Tonight, I invite you to relax, close your eyes, and let the soothing voice guide you through the stars. Take a deep breath, let the tensions of the day fall away, and allow your body to grow lighter, as if the very gravity of this universe is pulling you toward peaceful sleep. As we embark on this voyage, know that you have nothing to do but rest and let the wonders of the Milky Way unfold. You're not just listening to an ordinary night sky exploration. We are venturing into the heart of our home galaxy, the Milky Way, a vast spiral of stars, dust, and dark matter that has been turning slowly in space for over 13 billion years. But while it may look beautiful, our galaxy is much more than meets the eye. Hidden within its spiral arms lie stories of rogue stars, invisible forces, and cosmic mysteries that defy our understanding. In tonight's journey, we'll gently explore these secrets, traveling through stars older than the galaxy itself, cosmic collisions that have reshaped our universe, and mysterious black holes that pull at the fabric of space-time. From star nurseries where new stars are born, to rogue stars flung from the galactic core at unimaginable speeds, the Milky Way is full of cosmic phenomena that often go unnoticed. But don't worry, this is no rushed adventure. We will take our time, wandering quietly through this cosmic landscape, observing and letting the knowledge seep in gently. Some facts may surprise you, others may inspire a sense of wonder, but all of them will leave you with a deeper appreciation of the galaxy we call home. As we begin, I encourage you to subscribe to the Sleepy Science Facts so you can join us on more peaceful journeys through the wonders of the universe. If this peaceful exploration is helping you relax and unwind, consider liking this video so others can find their way here too. One sleepy soul at a time. You'll never miss out on a journey like this again. So, let's take a deep breath and begin. Tonight, we're focusing on the most calming facts about the Milky Way Galaxy, designed to lull you into a serene and restful sleep. Together, we'll drift through the secrets of this vast cosmic island, unraveling the mysteries of stars, galaxies, and the quiet motions that shape the universe. While the Milky Way may feel like a stable home, it is far from static. In fact, it is constantly evolving. Over the course of billions of years, the Milky Way has collided with and absorbed smaller galaxies, drawing them into its gravitational embrace. One of these galaxies, the Sagittarius dwarf, is currently being torn apart by the immense forces at work within our galaxy. Its stars are scattered into tidal streams that spiral around the Milky Way, a reminder of the violent past that shaped the galaxy we live in today. Even as we speak, another cosmic collision is slowly drawing near. The Andromeda Galaxy, our nearest large neighbor, is slowly making its way toward us. In about 5 billion years, these two great spirals will merge in a slow but monumental cosmic collision. While stars are so far apart that they almost never collide, the shape of both galaxies will change forever, creating a new, unified galaxy that will be as vast and quiet as it is beautiful. But the story of the Milky Way doesn't end there. Even now, the galaxy is continuing to grow. It's absorbing gas from the intergalactic medium, capturing stars from smaller galaxies and drawing streams of dark matter that feed its halo. This process of growth is not like the life of a living organism, but more like the deepening of a gravitational well. With each passing moment, the Milky Way continues to grow, change, and reshape itself. What's fascinating about this growth is that it's not always a quiet affair. Sometimes the galaxy grows gently, adding material quietly through clouds of gas that fill empty spaces. Other times, it's a more violent process, with entire satellite galaxies being torn apart, their stars scattered across the sky, adding to the Milky Way's growing mass. Our journey through the Milky Way also reveals the dynamic nature of its stars. Some of the stars you see in the night sky are ancient. In fact, there are stars in the Milky Way that are older than the galaxy itself. These ancient stars, known as halo stars, formed long before the Milky Way even began to take shape. These stars are often scattered across the sky in long, tilted orbits, and their chemical composition reveals little evidence of the heavier elements we see in stars born more recently. They are living fossils of a time before the Milky Way had fully formed, showing us a glimpse of the early universe. Wild and untamed, still learning to shape itself into the galaxies we see today. But the Milky Way's growth isn't just about stars. Our solar system, and indeed our entire galaxy, is constantly in motion. As our sun orbits the center of the Milky Way at more than 828,000 kilometers per hour, we are also moving through the galaxy at a steady pace. It takes us about 225 million years to complete one full orbit of the Milky Way's center. This path is known as a galactic year, and although the sun moves at an incredible speed, it's only completed about 20 orbits since the solar system formed, a tiny fraction of the time it will take to complete the full journey. Even the stars in the Milky Way are not static. They follow intricate winding paths around the center of the galaxy. Some stars, like our sun, are part of this grand cosmic dance, moving in and out of spiral arms. Other stars travel at different speeds, and some even move in retrograde motion, an orbit opposite to the rest of the galaxy. This motion tells the story of stars that were once part of other galaxies, now absorbed into the Milky Way, adding to the rich complexity of our galaxy's history. As we continue our journey through the Milky Way, we encounter a galaxy that is still in the process of evolving, expanding, and growing, quietly, without pause. While the Milky Way may seem ancient, it is not finished. Even now, our galaxy is constantly gathering new material, absorbing gas, stars, and dark matter from the universe around it. In a way, the Milky Way is a living, breathing cosmic entity, always reshaping itself as it pulls in the elements needed for new creation. This process of growth isn't immediate or chaotic. Instead, it happens gradually over time. At the edges of the Milky Way, distant clouds of gas and stars are slowly being drawn into the galaxy's vast gravitational pull. Some of this material arrives quietly, in the form of cold gas, streaming in from the intergalactic medium. It's a slow, steady influx of material, adding to the mass of the Milky Way without much fanfare. But the galaxy's growth doesn't always come so gently. There are times when the Milky Way experiences dramatic disruptions, particularly when it captures smaller galaxies. These smaller satellite galaxies, once independent, are torn apart by the immense gravitational forces of the Milky Way. Their stars are scattered across the galaxy, adding to the Milky Way's already vast stellar population. Some of these stars form new stellar streams, thin ribbons of light that wrap around the galaxy like ghostly halos. These stellar streams are the remnants of ancient galaxies that were consumed by the Milky Way. Perhaps the most fascinating aspect of this growth is that it has been happening for billions of years. The Milky Way isn't just one galaxy that formed long ago and has remained static. It is a dynamic, evolving system that has been shaped by countless mergers, cosmic encounters, and the slow accumulation of material. It's a galaxy that is constantly changing, constantly adding new pieces to its puzzle, reshaping itself in the process. One of the most significant sources of growth for the Milky Way is its satellite galaxies. The Milky Way has consumed dozens of smaller galaxies throughout its long history. Some of these galaxies were large and full of stars, while others were much smaller and less noticeable. Over time, as these galaxies drifted too close to the Milky Way, they were pulled into its gravitational embrace, ripped apart, and their stars scattered across the galaxy's vast disk. The process of galactic consumption is still ongoing. Right now, the Milky Way is in the midst of tearing apart a small galaxy known as the Sagittarius Dwarf. This galaxy, once an independent system of stars, is now being slowly dismantled by the gravitational forces of the Milky Way. As its stars are scattered, they form tidal streams that wrap around the Milky Way like faint traces of a distant past. This ongoing merger serves as a reminder that galaxies are not static. They are in constant motion, evolving through time. But what about the future? What does the Milky Way look like as it continues to grow? Well, in about 4.5 billion years, the Milky Way will merge with its neighboring galaxy, Andromeda. The two great spiral galaxies will collide in a slow, graceful dance that will reshape both galaxies. While individual stars will likely miss each other due to the vast distances between them, the shape of both galaxies will be forever altered. The Milky Way will no longer look the way we know it today. Instead, it will become a much larger galaxy, one that may resemble an elliptical galaxy more than the spiral galaxy we see now. This collision will be a monumental event, but it will also be a slow one. Over billions of years, galaxies like the Milky Way and Andromeda are constantly in motion, drifting toward one another due to the pull of gravity. The collision will not be a violent crash, but a gradual merging of their structures. The two galaxies will combine to form a single, larger galaxy, and over time, the new system will settle into a new shape. It's a reminder that galaxies are not eternal. They evolve, collide, and transform. Interestingly, stars in the Milky Way are not all following the same path. Most stars in the galaxy orbit the center in the same direction, but not all of them follow the rules. Some stars, particularly those in the outer halo, move in retrograde, meaning they orbit the center of the galaxy in the opposite direction. These stars are the remnants of ancient mergers and cosmic encounters. Their motion serves as a reminder of the galaxy's complex history, one that spans billions of years and is shaped by countless cosmic interactions. The movement of these stars tells a story of ancient mergers and cosmic upheavals that have shaped the galaxy into what it is today. When astronomers study the motion of stars in the Milky Way, they can trace the galaxy's history back through time, uncovering the remnants of long-forgotten galaxies that were once part of the Milky Way's growing body. These stars, like ancient witnesses, carry the echoes of a past that can never be fully erased. Another interesting aspect of the Milky Way's evolution is the galaxy's spiral arms. When we look at the Milky Way from a distance, it appears to have well-defined spiral arms like a grand pinwheel. But what if I told you that these arms are not fixed structures? They are patterns of density waves, waves of higher star density, moving through the galaxy's disk. As these waves pass through, they compress gas and trigger the formation of new stars. The spiral arms aren't solid structures, but rather a dynamic process of star formation and motion. As we journey further into the Milky Way, we'll explore these spiral arms in more detail and learn how they are shaped by the galaxy's rotation. But for now, just know that the galaxy is always in motion. Stars are born, live, and die, but the galaxy itself is a living, breathing entity that is constantly evolving. It's a reminder that even in the vast emptiness of space, there is constant change, constant growth, and constant motion. As we drift further into the Milky Way, we begin to realize that while the galaxy is a vast and beautiful expanse of stars, gas, and dust, there is much more hidden beneath the surface. Much of what we think we know about our galaxy is still shrouded in mystery. For example, one of the most intriguing aspects of the Milky Way and the universe in general is the invisible force that binds everything together: dark matter. Dark matter is a mysterious substance that makes up around 85% of the mass in the universe, yet we can't see it, touch it, or detect it directly. What we do know is that it exerts a gravitational force, holding galaxies like the Milky Way together, preventing them from flying apart as they spin through space. Without dark matter, the Milky Way would not have the structural integrity it does. It is the silent, invisible scaffolding that keeps everything in place. Although scientists have been trying to understand dark matter for decades, it remains one of the greatest puzzles in astrophysics. We can observe its effects on the motion of stars and galaxies, but we have yet to detect it directly. What's truly fascinating is that the presence of dark matter is inferred not through direct observation, but through its gravitational influence on visible matter. It's a reminder that much of the universe remains unseen, waiting for us to uncover its secrets. While dark matter may hold the galaxy together, the Milky Way structure itself is far more complex than it first appears. The galaxy's disk, where most of the stars reside, is not flat, but slightly warped. This subtle distortion was first detected through radio telescopes, which map the hydrogen gas that stretches far beyond the visible starlight. The warp in the disk suggests that something is pulling at the galaxy's edges, likely the gravitational forces of nearby dwarf galaxies or clumps of dark matter. This warping gives the Milky Way an unusual shape, one that bends and undulates as it moves through space. It's like a great cosmic sheet being tugged in different directions, an ever-changing form influenced by the forces around it. And just like this warp in the disk, the galaxy itself is not a perfect spiral. Some arms of the Milky Way are brighter or longer than others, and the distribution of stars is uneven, a subtle reminder that the galaxy's evolution is far from symmetrical. The Milky Way's star formation process is another part of the galaxy that continues to evolve. When we look up at the night sky, we are witnessing only a small fraction of the galaxy's full star population. There are over 100 billion stars in the Milky Way, but many of them are hidden from view, shrouded behind dense clouds of gas and dust. Some stars are so faint or so far away that we simply cannot see them with the naked eye. In fact, to see the full scope of the Milky Way, we would need to observe it using infrared or radio telescopes that can peer through the dust and reveal the stars hidden within. Star formation in the Milky Way happens primarily in the galaxy's spiral arms, which are rich in gas and dust. These regions, known as stellar nurseries, are the birthplace of new stars. The process begins when a massive cloud of gas and dust is compressed, either by the gravitational pull of other nearby clouds or by the shock waves from supernovae. As the gas compresses, it heats up, and eventually, nuclear fusion begins, and a new star is born. These stellar nurseries are chaotic, glowing regions where new stars ignite, lighting up the surrounding gas and dust in brilliant shades of blue and white. These newborn stars are often surrounded by swirling clouds of gas and dust, remnants of the original cloud from which they were born. Over time, the stars in these stellar nurseries move away from their birthplace, and new stars continue to form in the wake of the old. The spiral arms of the Milky Way are not solid structures, but dynamic, ever-changing patterns that trigger the formation of new stars and influence the overall structure of the galaxy. In addition to the spiral arms, the Milky Way's halo is another important feature of its structure. The halo is a vast spherical region surrounding the galaxy that contains ancient stars, globular clusters, and dark matter. While the halo is nearly invisible to the naked eye, it is thought to hold a significant portion of the Milky Way's mass. Some of the stars in the halo are thought to be remnants of smaller galaxies that were absorbed by the Milky Way in the distant past. These ancient stars, known as halo stars, are scattered across the sky in long, tilted orbits, providing clues to the Milky Way's past. The halo is also home to globular clusters, dense, spherical groups of stars that are among the oldest objects in the galaxy. These clusters are thought to be the remnants of early star formation, preserved in the outer regions of the Milky Way. Some of the stars in these clusters are more than 12 billion years old, making them some of the oldest stars in the universe. Studying these ancient stars can provide valuable insights into the early history of the Milky Way and the conditions that existed in the universe shortly after the Big Bang. While the Milky Way's core may seem quiet, it holds one of the most fascinating and powerful features of the entire galaxy, a supermassive black hole. At the center of the Milky Way lies Sagittarius, a star, a black hole that is more than 4 million times the mass of the Sun. Although we can't see the black hole directly, we can observe its effects on nearby stars. The immense gravitational pull of Sagittarius A star causes nearby stars to move at incredible speeds, tracing elliptical orbits around the black hole. Occasionally, gas and dust from surrounding regions fall into the black hole, creating a flare of energy as the material spirals inward and is heated to extreme temperatures. These energetic bursts of radiation are often detected as X-rays, giving us a glimpse of the immense power that lies at the heart of the galaxy. Sagittarius. A star may be dormant today, but in the past it could have been much more active, possibly even a quasar, a brilliant high-energy object that outshines entire galaxies. While we know that Sagittarius A star is at the center of the Milky Way, the galaxy's core is not as simple as a single point of gravity. It is surrounded by a complex peanut-shaped bulge, a region of stars and gas that is shaped by the gravitational forces at play within the galaxy. This bulge is likely the result of the galaxy's central bar, a dense concentration of stars that rotate slowly, pulling gas and dust toward the black hole. The combination of the bulge and the bar at the center of the Milky Way gives the galaxy's core its unique, intricate shape. But even as we study the Milky Way, we realize just how much remains unknown. The galaxy is vast and full of secrets, many of which we are only beginning to uncover. The invisible forces of dark matter and dark energy continue to elude our understanding, and the true nature of the galaxy's formation and evolution remains a subject of ongoing research. As we explore deeper into the Milky Way, we will continue to encounter new mysteries, new stars, and new revelations about the galaxy we call home. As we continue to explore the depths of the Milky Way, we move from the well-known stars and nebulae to the hidden wonders that lie just beyond our reach. The universe is full of phenomena that are almost invisible to the naked eye, but with the right instruments, we can peer through the darkness and uncover its mysteries. From supernovae to rogue stars, the Milky Way is full of secrets waiting to be discovered. One of the most fascinating and mysterious features of our galaxy is the concept of rogue stars, stars that are flung from the center of the galaxy and sent hurtling into the void. While most stars in the Milky Way move along regular orbits around the galactic center, a few are flung outward at incredible speeds. These rogue stars, also known as hypervelocity stars, are moving so quickly that they may eventually escape the Milky Way altogether, traveling through intergalactic space. The origin of these hypervelocity stars is still a subject of research. Some scientists believe they are the remnants of binary systems that were disrupted by the supermassive black hole at the center of the Milky Way. When one star in the binary system is pulled into the black hole, the other is slung outward at incredible speeds, becoming a rogue star. Other rogue stars may have been ejected by three-body encounters or by supernovae in binary systems, where the force of the explosion sends one star flying into space. These rogue stars travel alone, far from the galactic plane, like cosmic wanderers. Their existence serves as a reminder that even in a galaxy bound by gravity, there are moments of violent release. These stars are not bound to the galaxy. They are free to roam the vast expanse of intergalactic space, their light traveling far beyond the reach of the Milky Way. While rogue stars are a rare phenomenon, they represent the dynamic and unpredictable nature of the galaxy. They are a stark reminder that the Milky Way, despite its beauty and order, is a place of constant change and movement. Even stars, which seem so permanent, are subject to the forces of the universe, and some are cast away, never to return. But the Milky Way isn't just a place of rogue stars and hidden forces, it is also a cradle of creation. Within the spiral arms of the galaxy, we find stellar nurseries, regions where new stars are born from vast clouds of gas and dust. These stellar nurseries are some of the most energetic and dynamic places in the Milky Way. When massive clouds of gas and dust collide or are compressed by external forces, they trigger the formation of new stars. These newborn stars light up their surroundings, casting bright blue and white light across the gas and dust clouds, which glow with the intensity of creation. The process of star formation is a complex and beautiful one. It begins with the collapse of a gas cloud, where gravity pulls the gas together into denser regions. As the gas collapses, it heats up and nuclear fusion begins. This marks the birth of a new star. The surrounding gas and dust form a disk around the star, where planets may eventually form. Some of these stellar nurseries are so dense that they can be seen with infrared telescopes, revealing regions of intense star formation that are invisible to the naked eye. While star formation is an ongoing process, it is not without its challenges. The Milky Way is not as active in star formation as it once was. Over billions of years, the rate of star formation has slowed down. Much of the gas that once fueled the birth of new stars has been dispersed or locked away in forms that are difficult to collapse into new stars. The galaxy is still forming stars, but at a much slower pace than it did in the past. This slowing of star formation has led to a more mature galaxy. The Milky Way is no longer bursting with new stars in the same way it was in its early years. Instead, it has reached a sort of cosmic middle age. The galaxy is still alive, still growing, but no longer in a hurry. It's a reminder that even galaxies have life cycles. They are born, they grow, they evolve, and eventually they begin to slow down. But even as star formation slows, the Milky Way continues to recycle its material. Stars that die do not simply vanish into space. They return their material to the galaxy, enriching the interstellar medium with heavy elements that will eventually form new stars, planets, and even life. Supernovae, the explosive deaths of massive stars, release vast amounts of energy and heavy elements into space. These elements, including iron, calcium, and gold, are scattered across the galaxy, mixing with the gas and dust that will eventually form new stars and planets. The process of stellar recycling is essential for the continued evolution of the galaxy. Without it, the Milky Way would eventually run out of the raw materials needed to form new stars and planets. But because stars die and return their material to the galaxy, the cycle of creation and destruction continues. It's a cosmic dance, a never-ending process of birth, death, and rebirth. One of the most remarkable aspects of this process is that it happens on a galactic scale. The Milky Way is not just a collection of stars, it's a dynamic, evolving system, constantly creating, destroying, and reshaping itself. The stars, the gas, the dust, and the dark matter all interact in a complex web of forces, all governed by the laws of gravity. It's a reminder that even in the vastness of space, everything is connected. Every star, every planet, every piece of matter is part of a larger system, a system that is constantly changing and evolving. The Milky Way is not alone in this cosmic dance. It is part of a larger family of galaxies known as the Local Group. The Local Group is a collection of more than 50 galaxies bound together by gravity. The two largest members of the Local Group are the Milky Way and Andromeda, and these two galaxies are on a slow collision course. In about 4.5 billion years, the Milky Way and Andromeda will merge, forming a new, larger galaxy. The Local Group itself is not a static collection of galaxies. Over time, the galaxies within the group are moving closer together, slowly merging and interacting. Some of the smaller galaxies in the group are being pulled into the Milky Way, while others are being torn apart by the gravitational forces at play. The future of the Local Group is one of gradual evolution as galaxies merge, interact, and reshape themselves in response to the forces of gravity. As we continue to explore the Milky Way, we begin to see how interconnected everything is. The stars, the gas, the dust, and the dark matter are all part of a larger system, a system that is constantly changing and evolving. It's a reminder that even in the vast emptiness of space, there is a rhythm, a pattern that governs the universe. Everything is in motion, everything is connected, and everything has a purpose. As we continue our serene journey through the vast expanse of the Milky Way, let's turn our gaze to the vast neighborhoods that surround us, regions of the galaxy that are teeming with mystery and wonder. Our own solar system is located in a quiet section of the Milky Way. nestled in what's called the Orion Spur, a minor spiral arm tucked between the larger Sagittarius and Perseus arms. It may seem like a small corner of the galaxy, but this tranquil region has given rise to life as we know it. This quiet location in the galaxy structure is more significant than we might realize. If you were to look at the Milky Way from a distance, you'd notice that our solar system resides in an area that is somewhat free from the dangers that exist closer to the galactic core. The galactic core, home to the supermassive black hole Sagittarius A star, is an area of intense radiation and gravitational chaos. Beyond the core lies a sparsely populated halo where stars are more spread out and where interactions between stars are rare. In this peaceful region, the risks are lower. We live at just the right distance from the galactic center to avoid the constant radiation storms, supernovae, and gravitational disturbances that are much more common in other regions. Earth, our home, sits at the perfect balance, not too close to the volatile heart of the galaxy, and not too far out on the galaxy's periphery. This delicate position in the galactic plane has played a crucial role in allowing life to emerge and evolve. As we move through the galaxy, however, we are reminded that this peaceful corner is not permanent. Over time, the galaxy itself is shifting and changing. The Milky Way is not a static structure. It is a dynamic entity, constantly in motion and evolving. Even though we may feel secure in our quiet place within the galaxy, this neighborhood is far from stable. The Milky Way is growing and changing, and over billions of years, it will continue to reshape itself. In the distant future, our solar system will be pulled toward the galactic center as the Milky Way and Andromeda collide. As we discussed earlier, this collision is set to happen in about 4.5 billion years when the two galaxies merge into a single, larger galaxy. This process will dramatically alter the structure of both galaxies, reshaping the stars and planets within them. Our solar system, now in a calm, quiet region, will find itself in a much more dynamic and chaotic environment. Stars will be pulled into new orbits, and the landscape of the Milky Way will be forever transformed. But while this future may seem far away, it serves as a reminder of how small and fleeting our place in the universe is. In the grand timeline of cosmic events, the Milky Way has already experienced countless transformations. The galaxy has consumed smaller galaxies, reshaped its spiral arms, and even seen the formation of new stars. But all of this change is not a sign of destruction. It is the constant cycle of creation and rebirth that defines the life of galaxies. As we float through the galaxy, we also encounter one of the most awe-inspiring aspects of the Milky Way: its incredible number of stars. The galaxy is home to over 100 billion stars, each one with its own story, its own birth, and its own death. These stars, while incredibly distant, form the backbone of the Milky Way. They provide light, warmth, and energy to the planets and systems that orbit them. Our own sun is just one of these stars, a middle-aged star that has been burning for around 4.6 billion years. Though stars like our sun may seem permanent, they too have their own life cycles. Some stars live for billions of years, while others burn brightly for only a few million. The largest stars, known as massive stars, burn through their fuel quickly and end their lives in a spectacular supernova explosion. These explosions are so powerful that they can outshine entire galaxies for a brief period, releasing vast amounts of energy and scattering heavy elements into space. It's these supernovae that are responsible for creating the elements necessary for life, such as iron, carbon, and oxygen. When a massive star explodes, it enriches the surrounding space with these heavy elements, which eventually find their way into new stars, planets, and even life itself. This cycle of stellar birth, death, and rebirth is a crucial part of the galaxy's evolution, ensuring that the galaxy remains vibrant and full of life. But even as stars die, they leave behind remnants that continue to shape the galaxy. When a star reaches the end of its life, it can collapse into a dense, compact object known as a white dwarf, neutron star, or black hole. These stellar remnants continue to exert a gravitational influence on the surrounding space, shaping the galaxy in subtle ways. Black holes, in particular, are some of the most mysterious and powerful objects in the galaxy. They form when massive stars collapse under their own gravity, creating an infinitely dense point in space known as a singularity. At the center of the Milky Way lies one such black hole, Sagittarius A star. This supermassive black hole is more than 4 million times the mass of our Sun, yet it occupies a space smaller than the orbit of Mercury. We cannot see it directly, but we can observe its effects on the stars around it. The gravity of Sagittarius A star causes nearby stars to orbit at incredible speeds, tracing elliptical orbits around the black hole. Occasionally, gas and dust from surrounding regions are drawn into the black hole, creating a flare of energy as the material is heated to extreme temperatures. Although we cannot see black holes directly, their presence is undeniable. They are the silent, invisible forces at the heart of galaxies, controlling the motion of stars and gas in their vicinity. And while the black hole at the center of the Milky Way is relatively quiet today, it may not always have been. In the past, it may have been much more active, possibly even a quasar, a brilliant, high-energy object that outshines entire galaxies. As we continue our journey, we come to realize that the Milky Way is not just a collection of stars and planets. It is a dynamic and evolving system, shaped by the forces of gravity, dark matter, and the life cycles of stars. And while we may live in a relatively calm corner of this vast galaxy, the forces that shape it are constantly at work, reshaping the galaxy over time. The Milky Way is a living, breathing entity, a galaxy that is always in motion, always evolving, and always creating. As we continue our quiet journey through the Milky Way, we begin to realize that what we see with the naked eye is only a tiny fraction of what the galaxy truly holds. The visible stars, planets, and nebulae are only part of the story. Behind them lies a galaxy that is constantly changing, shaped by forces we cannot see but can detect by their effects. From invisible dark matter to the slow but steady movements of stars, the Milky Way is an intricate web of forces and phenomena, all working together to shape its ever-changing form. One of the most mysterious elements of the galaxy is dark matter. Although we cannot directly observe dark matter, its presence is felt everywhere. In fact, it makes up about 85% of the galaxy's total mass. It is called dark because it doesn't emit, absorb, or reflect light, making it invisible to our telescopes. However, we can infer its existence by studying the motion of stars and gas in the galaxy. The gravitational influence of dark matter helps hold the Milky Way together, preventing it from flying apart as it spins through space. The presence of dark matter is particularly evident in the way galaxies rotate. According to classical physics, stars at the edge of the Milky Way should be moving slower than those near the center. However, astronomers have discovered that the stars in the outer regions of the galaxy move at nearly the same speed as those near the center. This unexpected behavior can only be explained by the presence of a massive, invisible substance, dark matter. Without dark matter, the stars at the edge of the galaxy would simply be flung into space. But dark matter is not the only invisible force at play in the Milky Way. The galaxy is also influenced by dark energy, a mysterious force that is causing the universe to expand at an accelerating rate. While dark matter pulls things together through gravity, dark energy pushes everything apart, causing galaxies to move away from each other at increasing speeds. The exact nature of dark energy is still unknown, but it is believed to make up about 68% of the total energy content of the universe. Together, dark matter and dark energy form the unseen skeleton of the galaxy, guiding its evolution and influencing its structure. In addition to these invisible forces, the Milky Way is also shaped by the stars themselves. As we've learned, stars are born, live, and die, each one contributing to the galaxy's ever-changing landscape. But stars do not live forever. When a star reaches the end of its life, it undergoes a dramatic transformation, and its death can have a profound impact on the galaxy around it. Some stars end their lives in supernovae, massive explosions that release vast amounts of energy and heavy elements into space. These explosions are among the most energetic events in the universe, outshining entire galaxies for brief moments. The shock waves from supernovae can compress nearby gas clouds, triggering the formation of new stars. The materials ejected by these explosions, including iron, calcium, and gold, enrich the interstellar medium, contributing to the formation of future stars and planets. But supernovae are not the only way stars affect their surroundings. Some stars end their lives by collapsing into black holes or neutron stars. These stellar remnants continue to exert a gravitational influence on the galaxy, pulling in nearby gas and stars. The most massive black holes, like the one at the center of the Milky Way, can even affect the motion of stars across the entire galaxy. Sagittarius. A star, the supermassive black hole at the center of our galaxy, is over 4 million times the mass of our Sun. Its immense gravitational pull affects the orbits of stars in its vicinity, causing them to move at incredibly high speeds. At the same time, some of the most fascinating phenomena in the Milky Way are the products of the interactions between stars and the gas and dust that fill the galaxy. The spiral arms of the Milky Way, for example, are not fixed structures made of solid stars, but dynamic patterns formed by density waves that move through the galaxy. As these waves pass through regions of gas and dust, they compress the material, triggering the formation of new stars. These stars then move away from the density wave, creating a self-sustaining spiral pattern that gives the galaxy its signature shape. But the galaxy's spiral arms are not as simple as they may seem. The Milky Way spiral arms are not evenly distributed around the galaxy. Some arms are longer and brighter than others, while some fade away entirely. This uneven distribution is due to a variety of factors, including the influence of dark matter, the motion of stars, and the complex dynamics of the galaxy's evolution. Some astronomers even believe that the Milky Way's spiral structure may not be fixed at all, but constantly changing over time. The formation of stars in the spiral arms is also influenced by the presence of molecular clouds vast, dense regions of gas and dust where new stars are born. These clouds are the nurseries of the galaxy, where gravity slowly pulls the gas together, creating dense regions that collapse into new stars. Some of these clouds are so massive that they can span hundreds of light years across, containing enough gas to form millions of stars. These molecular clouds are not isolated, however. They are constantly interacting with one another, colliding and merging, which can trigger the formation of even more stars. Some of these clouds are also the remnants of ancient stars, long dead, but still contributing to the ongoing process of star formation. The Milky Way is a place of constant creation and destruction, where stars are born, live, and die, each one contributing to the overall evolution of the galaxy. One of the most exciting aspects of the Milky Way is the discovery of new stars and planets. Thanks to advanced telescopes and space observatories, astronomers are constantly uncovering new exoplanets, planets that orbit stars outside our solar system. These planets vary widely in size, composition, and distance from their stars. Some are gas giants, while others are rocky worlds similar to Earth. The search for life beyond our planet is one of the driving forces behind the exploration of exoplanets. And with each new discovery, we come closer to understanding the potential for life elsewhere in the galaxy. In fact, our search for life beyond Earth is closely tied to our understanding of the galaxy's habitable zone. Just as Earth orbits our Sun in a region that is neither too hot nor too cold for life to exist, astronomers believe that there may be other habitable zones in the Milky Way, regions where conditions are just right for life to thrive. These zones are often located at just the right distance from stars, where the temperature is mild enough for liquid water to exist. The discovery of these zones, combined with the search for exoplanets, has opened up new possibilities for the existence of life elsewhere in the galaxy. But even as we search for life, we must remember that the Milky Way is vast. It spans over 100,000 light years across and contains over 100 billion stars, many of which are hidden from our view. The galaxy is a place of immense scale and beauty, and even though we may only be able to observe a small portion of it, the mystery of the Milky Way continues to captivate and inspire us. As we move further into the heart of the galaxy, we will continue to uncover new wonders, hidden stars, strange phenomena, and the unseen forces that shape the galaxy. The Milky Way is a living, evolving entity, full of secrets waiting to be discovered. And as we continue our peaceful journey through its vast expanse, we are reminded of the beauty and mystery that lies beyond the stars. As we drift through the Milky Way, we encounter even more secrets hidden within its vast expanse. The galaxy is not only a vast collection of stars and gas, but a dynamic and constantly evolving system, shaped by forces that we are still trying to fully understand. From star clusters that once formed together to mysterious cosmic phenomena that stretch the boundaries of our knowledge, the Milky Way is full of celestial wonders that tell the story of its creation and transformation. One of the most fascinating features of the Milky Way is its stellar clusters. These clusters are groups of stars that formed from the same cloud of gas and dust. These stars share a common origin, and as they orbit the galactic center together, they create a collective structure that is much more than the sum of its parts. These clusters are like families of stars, each one bound together by gravity, moving through the galaxy as a unit. There are two main types of stellar clusters: open clusters and globular clusters. Open clusters are young groups of stars, often found in the spiral arms of the galaxy, where new stars are still being born. These clusters are relatively loosely bound, and over time, the stars tend to drift apart as they interact with the gravitational forces of other stars and galaxies. Despite this, open clusters remain a vital part of the galaxy's star-forming regions, providing the raw material for new stellar systems. On the other hand, globular clusters are much older and more tightly bound than open clusters. These ancient groups of stars can be found in the outer halo of the Milky Way, far from the spiral arms where new stars are born. The stars in globular clusters are some of the oldest in the galaxy, and many of them have been orbiting the galactic center for billions of years. These clusters are incredibly stable, and their stars remain in a close gravitational relationship, making them perfect laboratories for studying the early history of the Milky Way. But even as we explore the beauty of these clusters, we begin to realize that stars are not the only objects that influence the galaxy's evolution. The Milky Way is also shaped by invisible forces, forces that govern the motion of stars, gas, and even galaxies themselves. One of the most significant of these forces is the influence of dark matter, a mysterious substance that makes up most of the galaxy's mass, but cannot be seen directly. Dark matter is thought to exist in the form of a vast halo that surrounds the Milky Way. While the stars and gas we observe make up only a small portion of the galaxy's total mass, dark matter constitutes the bulk of the galaxy's mass. This invisible matter exerts a gravitational force on the visible stars, gas, and dust, helping to hold the galaxy together and preventing it from flying apart as it spins. Despite its invisible nature, the presence of dark matter is essential to the galaxy's structure and stability. Without it, the Milky Way would not have the gravitational pull necessary to maintain its shape. This unseen matter helps to anchor the galaxy's stars and gas, ensuring that everything remains in its place. The discovery of dark matter has been one of the most significant breakthroughs in modern astronomy, and yet it remains one of the galaxy's greatest mysteries. As we move deeper into the heart of the Milky Way, we encounter one of the most intriguing and enigmatic features of the galaxy, the supermassive black hole at its center. This black hole, known as Sagittarius A star, is a gravitational titan with a mass more than 4 million times that of our Sun. Despite its immense size and power, this black hole remains invisible to our eyes. We cannot see it directly, but we can observe its effects on the stars and gas that surround it. The stars near Sagittarius A star move at incredibly high speeds, tracing elliptical orbits around the black hole. The immense gravitational pull of the black hole causes these stars to move in tight, rapid orbits, tracing out paths that have been shaped by its gravity. Occasionally, gas and dust from the surrounding regions are drawn into the black hole, creating a flare of energy as the material is heated to extreme temperatures. These energetic bursts of radiation can be detected as X-rays, giving us a glimpse into the immense power of the black hole. But even as we observe the effects of Sagittarius A star on its surroundings, we are reminded that this supermassive black hole is not unique. In fact, nearly every large galaxy in the universe is thought to have a supermassive black hole at its center. These black holes play a crucial role in the evolution of galaxies, influencing the motion of stars and gas, and even triggering the formation of new stars. Some astronomers believe that the growth and activity of these black holes may be linked to the overall growth of the galaxies themselves. As we move beyond the central region of the Milky Way, we encounter one of the most fascinating aspects of the galaxy's evolution, its ongoing star formation. While the Milky Way has slowed down its rate of star formation in recent years, the process is far from over. New stars are still being born in the galaxy's spiral arms, fueled by vast clouds of gas and dust. These stellar nurseries are the birthplace of new generations of stars, each one contributing to the ongoing cycle of creation and destruction that defines the galaxy. In these stellar nurseries, the gas and dust that have been scattered across the galaxy collide and compress, triggering the formation of new stars. Some of these stars are massive, burning brightly and quickly before eventually collapsing into supernovae. Others are smaller, living for billions of years before fading into white dwarfs or neutron stars. These new stars are the lifeblood of the galaxy, ensuring that the Milky Way continues to grow and evolve over time. The cycle of star formation is not just a natural process, it is a fundamental part of the galaxy's existence. Without it, the Milky Way would eventually run out of the material needed to form new stars, and the galaxy would gradually fade away. But as long as the process of star formation continues, the Milky Way will remain a vibrant, ever-evolving system, full of life, energy, and mystery. And yet, even as the Milky Way continues to grow and evolve, it is not the only galaxy in the universe. Our galaxy is part of a larger cosmic structure known as the local group, a collection of more than 50 galaxies that are bound together by gravity. The Milky Way and its closest neighbor, the Andromeda Galaxy, are the largest members of the local group, and the two galaxies are on a slow collision course. In about 4.5 billion years, the Milky Way and Andromeda will merge, creating a new, larger galaxy that will reshape the entire local group. As we continue our journey through the Milky Way, we are reminded that our galaxy is part of something much larger, a vast, interconnected universe full of galaxies, stars, and cosmic wonders. The Milky Way may be our home, but it is just one piece of the puzzle. And as we look deeper into the cosmos, we realize that the universe is full of mysteries waiting to be uncovered. As we journey further into the heart of the Milky Way, we begin to understand that the galaxy is not just a collection of stars, but a living, breathing system, constantly evolving and reshaping itself over billions of years. The stars, planets, gas, dust, and even dark matter that make up the Milky Way are all part of a complex web of forces that have been at work since the very beginning of time. And even as the galaxy continues to grow and change, it is not isolated. It is part of a larger cosmic structure, one that is constantly shifting and evolving. One of the most fascinating aspects of the Milky Way is its connection to other galaxies. While the Milky Way may seem vast and endless, it is just one of billions of galaxies in the universe. And yet, even in this vast expanse, galaxies are not scattered randomly across space. They are part of larger groups, bound together by the invisible forces of gravity. The Milky Way is part of a small group of galaxies known as the local group. This collection of more than 50 galaxies includes not only our own galaxy, but also Andromeda, the closest large galaxy to the Milky Way. Andromeda, like the Milky Way, is a massive spiral galaxy, and the two are on a slow collision course. Over the next 4.5 billion years, the Milky Way and Andromeda will merge, forming a new, larger galaxy that will forever change the landscape of the local group. This cosmic dance between galaxies is not a new phenomenon. In fact, the Milky Way has experienced many such encounters throughout its long history. Over billions of years, the galaxy has collided with and absorbed smaller galaxies, each merger leaving its mark on the structure and evolution of the galaxy. These cosmic collisions are a natural part of the galaxy's growth, and they have shaped the Milky Way into the spiral galaxy we know today. But while these mergers may seem violent, they are often slow and graceful. The stars in each galaxy are so far apart that they rarely collide. Instead, the galaxies pass through each other, their gravitational forces causing the stars and gas to interact, triggering the formation of new stars and the reshaping of the galaxy structure. Over time, the galaxies will merge, their spiral arms coiling together, forming a new, larger galaxy that will continue to evolve over billions of years. The Milky Way itself is a product of this cosmic dance. Over time, it has absorbed numerous smaller galaxies, their stars scattered throughout the galaxy's disk and halo. These mergers have left behind a rich tapestry of stellar streams, thin ribbons of stars that trace the paths of ancient galaxies that were consumed by the Milky Way. These streams are remnants of a time when the Milky Way was still growing, and they provide us with a glimpse into the galaxy's complex and violent past. But even as the Milky Way continues to grow and change, we must also consider the future. In about 4.5 billion years, the Milky Way will collide with Andromeda, and the two galaxies will merge into a single, larger galaxy. The collision will cause both galaxies to reshape, their stars and gas merging to form a new, more massive system. The spiral arms will twist and merge, creating a new galaxy with a completely different structure. While the collision between the Milky Way and Andromeda is inevitable, it is not something to fear. The vast distances between stars mean that the likelihood of stars colliding directly is extremely low. Instead, the galaxies will pass through each other, their shapes changing over time as they interact gravitationally. The resulting galaxy will be much larger than the Milky Way or Andromeda, and it will continue to evolve for billions of years to come. But this collision is just one part of the larger cosmic cycle. Galaxies like the Milky Way and Andromeda are not static. They are constantly evolving, merging, and interacting with each other. This process of cosmic evolution is ongoing, and it shapes the structure and future of the universe itself. The Milky Way's connection to other galaxies is just one example of the cosmic cycles that govern the universe. From the birth of stars to the death of galaxies, everything in the universe is part of a larger interconnected system. The forces that shape the Milky Way are not unique to our galaxy. They are part of a larger pattern that extends throughout the universe. Galaxies are born, they grow, they collide, and they merge. And in this ongoing cycle, new stars and planets are created, while old ones die and return their material to the cosmos. This cosmic cycle is not limited to galaxies. It is also reflected in the life cycle of stars. Stars, like galaxies, are born, live, and die, each one contributing to the larger cycle of creation and destruction. Some stars die in supernovae, exploding in a brilliant burst of energy that scatters heavy elements across the galaxy. Other stars end their lives by collapsing into black holes, neutron stars, or white dwarfs, remnants of once mighty suns that continue to shape the galaxy long after their death. The death of stars is not an end, but a new beginning. The elements created in these stellar explosions are scattered throughout the galaxy, enriching the interstellar medium with the building blocks for new stars and planets. This process of stellar recycling ensures that the galaxy continues to evolve, creating new generations of stars and planets that will one day give rise to new forms of life. As we drift further into the heart of the galaxy, we are reminded of the larger cosmic cycles that govern the universe. The Milky Way is not a static entity. It is a dynamic and evolving system, shaped by the forces of gravity, dark matter, and the life cycles of stars. The galaxy is constantly changing, constantly growing, and constantly interacting with the galaxies around it. And as we continue our journey through this vast and beautiful system, we are reminded that the universe itself is a living, breathing entity, constantly shifting, growing, and evolving. Even as we watch the Milky Way slowly merge with Andromeda, we know that this is not the end. The galaxy will continue to evolve, continue to grow, and continue to shape the universe for billions of years to come. And as we continue our journey, we will see how these cosmic cycles unfold, shaping the galaxy and the universe in ways we can only begin to understand. As we venture deeper into the heart of the Milky Way, we find ourselves approaching one of the most mysterious and awe-inspiring regions of our galaxy, the galactic core. This central region is where the galaxy's gravity is at its most intense, a place where stars and gas are in a constant cosmic dance, influenced by the immense gravitational pull of an enigmatic object, Sagittarius A star, the supermassive black hole at the center of the Milky Way. At the core of the Milky Way lies a region of intense energy and gravitational forces. Sagittarius A star is a black hole that holds the center of the galaxy in its grasp. This black hole is more than 4 million times the mass of our Sun, making it one of the largest known black holes in the universe. Yet, despite its incredible size, Sagittarius A star remains invisible to our eyes. We cannot see it directly, but we can observe its effects on the stars that orbit around it. The stars near the galactic center move at incredible speeds, orbiting the black hole in elliptical paths. These stars are so close to the black hole that their orbits are distorted, stretched by the immense gravitational pull of the singularity at the center. Some stars move at speeds greater than 1 million kilometers per hour, tracing out their orbits in a region of space where time and space are warped by the black hole's gravity. This gravitational influence extends far beyond just a few stars. The entire galactic core is shaped by the presence of Sagittarius A star, its immense gravity dictating the movement of stars, gas, and even entire clusters of stars. It's as if the black hole at the center of the Milky Way is the beating heart of the galaxy, pulsing with the force of gravity, influencing everything in its vicinity. While Sagittarius A star is certainly the most prominent feature of the galactic core, it's not the only object that contributes to the dynamic environment of the center. The galactic center is also home to a vast amount of gas and dust, much of it in the form of molecular clouds. These clouds are dense regions of gas that contain the raw material for new stars to form. In fact, the galactic core is one of the most active star-forming regions in the Milky Way. The gas in the galactic core is constantly being drawn towards Sagittarius A star, where it spirals inward, slowly being consumed by the black hole. As the gas falls toward the black hole, it heats up, emitting X-rays and other forms of radiation. This process, known as accretion, creates a glowing disk of gas around the black hole, one of the brightest sources of radiation in the galaxy. But not all the gas in the galactic center is consumed by Sagittarius A star. Some of it is ejected back into the galaxy, creating powerful jets of high-energy particles that shoot outward from the black hole's poles. These jets can stretch for thousands of light years, sweeping through the galaxy and influencing the surrounding space. One of the most remarkable features of the galactic core is the presence of supernova remnants. Supernova, the explosive deaths of massive stars, are common in the central region of the Milky Way. When a star explodes in a supernova, it releases vast amounts of energy and material, scattering heavy elements into space. These explosions are so powerful that they can outshine an entire galaxy for a brief period, creating shock waves that propagate outward, compressing gas and triggering the formation of new stars. At the galactic center, these supernovae contribute to the ongoing cycle of creation and destruction. The shock waves from these explosions can trigger the collapse of nearby gas clouds, leading to the birth of new stars. At the same time, the intense radiation from the supernova can push gas away from the center, clearing out regions of space and preventing new stars from forming in those areas. The galactic core is not just a place of creation, but also of destruction. The black hole at the center, with its immense gravitational pull, can rip apart entire stars, consuming them and leaving behind only their remnants. These remnants are often scattered throughout the surrounding region, creating a chaotic and violent environment that is constantly in flux. Yet, despite this apparent violence, the galactic core remains a place of immense beauty and mystery, a place where the forces of gravity, radiation, and cosmic events all come together to shape the galaxy. As we move beyond the core, we begin to see how the influence of Sagittarius A star extends throughout the entire galaxy. The supermassive black hole at the center of the Milky Way is not just a feature of the galactic core. It is the anchor that holds the galaxy together. Its gravitational influence affects the motion of stars and gas throughout the galaxy, helping to maintain the overall structure of the Milky Way. In fact, the presence of a supermassive black hole at the center of most galaxies is thought to be a common feature of galaxy formation. Observations of distant galaxies have shown that many of them also contain supermassive black holes at their centers, and these black holes play a crucial role in the formation and evolution of the galaxies themselves. While Sagittarius A star may be the most famous supermassive black hole in the Milky Way, it is far from unique. In fact, some galaxies contain black holes that are much larger, millions or even billions of times the mass of our Sun. These massive black holes are thought to have played a crucial role in the formation of galaxies, helping to shape their structure and growth. But the true nature of supermassive black holes remains one of the greatest mysteries in astrophysics. We still do not fully understand how they form or how they influence the galaxies they inhabit. Some theories suggest that they are the remnants of the first stars that formed in the early universe, while others propose that they are the result of the merging of smaller black holes over time. Whatever the answer may be, one thing is clear: supermassive black holes are an essential part of the universe's cosmic architecture, shaping the structure and evolution of galaxies across the cosmos. As we continue to explore the Milky Way and beyond, we are reminded that the universe is a place of constant change and mystery. The galactic core is just one of many regions where cosmic forces are at work, creating stars, black holes, and galaxies. And while we may never fully understand the forces that govern the universe, the more we learn, the more we come to appreciate the quiet power and beauty that lies at the heart of the cosmos. As we continue our peaceful journey through the Milky Way, we begin to appreciate the larger context in which our galaxy resides. The Milky Way, while vast and beautiful, is just one of billions of galaxies scattered throughout the universe. And as we look beyond the confines of our own galaxy, we realize that the Milky Way is part of a larger cosmic structure, a structure that is constantly evolving and expanding. The Milky Way is part of a small group of galaxies known as the local group. This group contains more than 50 galaxies, but it is dominated by two massive spirals, the Milky Way and its closest neighbor, the Andromeda Galaxy. The two galaxies are gravitationally bound to each other, and over the next 4.5 billion years, they will collide, merging into a single, larger galaxy. While this collision will be a dramatic event, it will not be as violent as it might seem. The vast distances between stars ensure that direct collisions are rare, and the two galaxies will simply pass through each other, eventually combining into one. Beyond the local group, the Milky Way is part of a larger structure known as the local supercluster. The local supercluster is a vast collection of galaxies, galaxy groups, and clusters that are bound together by gravity. It spans over 10 million light years and contains thousands of galaxies, including the Milky Way and Andromeda. Within this supercluster, galaxies are constantly moving, interacting, and merging, creating a dynamic and ever-evolving cosmic structure. The local supercluster is just one of many superclusters that dot the universe. These superclusters are the largest known structures in the cosmos, and they are formed by the gravitational attraction between galaxies. Within each supercluster, galaxies are clustered together into groups and clusters, with some regions being more densely packed than others. The Milky Way, for example, is part of a small group of galaxies known as the local group, which is located near the outskirts of the local supercluster. However, the local supercluster itself is only a tiny fraction of the universe, which contains billions of such superclusters, all spread across vast expanses of space. Even beyond the local supercluster, the universe continues to expand. In fact, the expansion of the universe is one of the most remarkable discoveries in modern astrophysics. It was first observed by astronomer Edwin Hubble in the 1920s, when he noticed that galaxies were moving away from each other, with those farther away receding at faster speeds. This observation led to the realization that the universe itself is expanding, with galaxies moving away from each other as space itself stretches. The expansion of the universe is driven by a mysterious force known as dark energy. Dark energy is thought to make up about 68% of the total energy content of the universe, and it is responsible for the accelerated expansion of the cosmos. While we know that dark energy exists because of its effects on the universe's expansion, its exact nature remains one of the greatest mysteries in modern science. Some theories suggest that dark energy is a fundamental property of space itself, while others propose that it is the result of a new form of energy that is not yet fully understood. The universe's expansion is not uniform. In some regions, galaxies are moving away from each other at incredible speeds, while in other regions, galaxies are moving towards each other due to the gravitational pull of nearby objects. This movement is not random, but follows a pattern that is influenced by the large-scale structure of the universe. The universe is not just a random scattering of galaxies, it is a dynamic, interconnected system, with galaxies, clusters, and superclusters, all playing a role in the cosmic dance. As we look beyond the Milky Way and its immediate neighborhood, we begin to see the true scale of the universe. The Milky Way is just one galaxy among billions, each with its own stars, planets, and cosmic phenomena. And even beyond the galaxies, there are larger structures, superclusters, filaments, and voids that shape the universe's evolution. The universe is vast, and its complexity is staggering. From the birth of stars to the death of galaxies, every corner of the cosmos is a reflection of the forces that govern the universe. But as we look out into the universe, we are reminded that we are not simply passive observers of the cosmos. We are active participants in the story of the universe. The Milky Way is our home, and everything we know, everything we hold dear, exists within this vast and beautiful galaxy. As we continue to explore the cosmos, we are uncovering the mysteries of the universe piece by piece, and with each discovery, we come closer to understanding our place in the grand tapestry of the cosmos. One of the most profound realizations that comes with exploring the Milky Way and the universe is the realization of how connected everything truly is. The stars, the gas, the dust, and the dark matter that make up the galaxy are all interconnected, bound together by the forces of gravity and the laws of physics. The galaxies, the stars, and the planets are all part of a larger system, a system that is constantly evolving, growing, and changing. And within this system, we are all just tiny pieces of a much larger whole. As we move through the galaxy, we begin to see the intricate patterns that define the universe. We see the formation of stars, the death of galaxies, and the vast stretches of empty space that separate everything. Yet even in the emptiness, there is beauty, there is mystery, and there is the promise of discovery. The universe is constantly evolving, and with every passing moment, we are one step closer to understanding the cosmic forces that shape our existence. As we conclude our exploration of the Milky Way and its place in the universe, we are reminded that the universe is not just a vast, empty expanse. It is a living, breathing entity, full of life, energy, and mystery. From the birth of stars to the death of galaxies, everything in the universe is interconnected, and every discovery we make brings us one step closer to understanding the grand cosmic plan. The universe is vast, but it is also beautiful, and as we continue to explore, we will uncover new wonders that will inspire awe and wonder for generations to come. Till then, peace.